Hi, my name is Jamal, and I'm going to be talking about multiple item guidance. And while I can't go into all of the experiments in as much detail as I'd like, I do have a link to the preprint at the end where if you're interested to find out more, you can just scan it with your phone and it'll bring that up. Okay, so previous work has shown that a single working memory item automatically guides attention, but whether this occurs for two items is less clear. And if it does occur for two items, it could be the case that both items guide attention equally, or that only one active working memory item guides attention for one reason or another. And so to determine whether we find guidance at working memory set size 2, we have participants maintain one and two items over a short delay. And on the majority of trials, they perform a search task where color is irrelevant. They just need to report the orientation of that line. And on the remainder of trials, we test their memory. And on some set size 2 trials, we introduced this free report condition where participants were free to pick which item they'd like to report. And this should estimate whether there are any asymmetries present between those two items, because the literature has suggested that when multiple items are maintained, each one is maintained with an independent precision, that there's variability between these items, and that this variability is directly due to independent noise accumulating across all items. So we just want to see whether there are any asymmetries in memory, like if one item is represented better, and here we'll get an idea about the average memory strength. And if we look at the results, we do find these differences in memory strength at set size 2, and on the y-axis I'm plotting memory strength, TCC D prime, and like canonical D prime, higher is better, and if you're interested in more, I'll have a link to the preprint and to some videos that you can find out more. And so back to these results, what we find when participants are maintaining two items, when they're free to report one of those items, they report an item that's maintained almost as precisely as if they were maintaining only a single item. You compare these two bars. And when we randomly probe their memory, we find this substantial decrease in memory strength, suggesting that two items are maintained with this drastic differences in variability. And despite this, we still find that when one item is maintained or two items, we find strong attentional guidance, that participants are biased towards colors when they appear in the search display. So this allows us to conclude that attention is guided when two working memory items are active, but whether one or both working memory items are capable of guiding attention remains unclear, and we'll investigate that next. So to determine whether this well-represented item is responsible for the guidance as opposed to both exerting equal, we have participants now remember only two colors, and memory was tested at the end of every trial, and we still included the free report. And this will allow us to detect participants' search effect and then test their memory representation, so we can correlate how memory strength and search relate. And if we look at the search effect on the right, the y-axis is just the difference between those 2 points I showed before, so larger is better, shows greater influence by working memory representations. We replicate the effect in the blue bar, but what's critical here is that when participants freely reported an item that was present, we find a search effect, but when they chose an item that was absent from the search display, we find no guidance. And because we find these differences between free report and forced report, these well-represented items guide, and this secondary, this unchosen, poorly represented item does not guide attention. And so these data demonstrate, or at least suggest, that one of these items is responsible for the guidance, and that on average it's this well-represented one. And so while we find variability that's consistent with the literature and suggests that this variability occurs naturally as noise and memory accumulates independently across items, signal detection theory includes this sorts of variability and suggests that how familiar the signal for your memory item feels on a given trial is going to be noisy. And so when you encode two items like purple and green, you do so with roughly equal precision, D prime about 2. But on any given trial, the actual familiarity will vary such that sometimes the noise representation gets a stronger familiarity signal than the actual one that you encoded, like here in trial 2. And so we can take these principles of signal detection theory and ask, if we take the D prime on forced report trials and say, how precise would we expect the most precise memories to be? We can estimate participants' D prime on an individual subject level on free report trials. And what we find is that the predicted free report from forced report trials exclusively nicely correlates with their actual free report. suggesting that the variability that we see between forced and free report is accounted for by signal detection theory, and that this is a natural, inherent process to the noisy memory system that we have. And so some accounts, however, suggest that the focus of attention guides only for items within it, but then they don't offer suggestions or investigate how memory strength might be related to items within the focus of attention. And we wanted to find out whether the focus of attention adds some special status, allowing weaker memories to exert more control than memory strength alone would predict. And so to do that, we introduce retro cues to put an item in the focus of attention, and we manipulate memory strength independently. And what we find is that the focus of attention on directed cues produces better memories than the neutral cues, but they track the search effect, suggesting that no, the focus of attention doesn't provide some special status. Instead, it induces better memory strength, and that in turn gives better guidance. And so in conclusion, working memory items are maintained with differential representational fidelity, and on average only one item is going to be represented well enough to guide attention. That memory strength differences between forced and free report are predicted by signal detection theory and the TCC model that we estimate memory with. That the focus of attention doesn't grant a special status. Instead, it facilitates memory strength and therefore increases the likelihood of guidance. And lastly, across all experiments, memory strength predicts the observed search effect, memory strength here on the x-axis and search effect on the y-axis, across all experiments, within and across experiments, without needing to invoke the focus of attention. Thanks.